Hello everyone, this is Aman Agarwal and welcome to the first video of embedded system using atmega16 course. As this is the first tutorial, we'll learn very basic things about atmega16, that is how to program it in embedded C, how to glow an LED using it, and we'll make some patterns of multiple LEDs. We'll also simulate the results in the Proteus software. So let's get started with the coding part. The coding environment we are going to use for this course is the Atmel Studio. You can download any version that is compatible with your system. I have installed the Atmel Studio 7, which is the latest one. So let's get started with a new project. Also remember, you should have basic knowledge of C, otherwise this course is going to be a little difficult for you. So after pressing the new project, here comes the list of compilers. We have to select the GCC executable project for the embedded C and we'll name it as LED pattern. Make sure that you don't write any spaces between the name. Use underscore instead. So this is the list of microcontrollers that this software supports. We have to select the atmega16 IC. So let's search for it. Here is the atmega16. Click OK. So let me just debrief you about what is atmega16 IC. atmega16 IC consists of 40 pins and it has 4 input and output ports. These are the 4 input-output modules: the port A, port B, port C and port D. Each of these ports has 8 pins starting from pin A0 to pin A7. Similarly, pin B0 to B7, C0 to C7 and D0 to D7. Each of these pins can be used either as an input or an output. If we select a pin as an input, then it has 2 states, that is on and off. The on state is represented by 1, which will give plus 5 volts, and 0 will give off mode, that is 0 voltage on the device connected. But we have to first define whether we are going to use port or the pin as inputs or output. So as there are only 2 states, that is 0 or 1, all the code we write are binary codes. So let's get started with the coding now. First we have to include the io.h header file, that is input-output.h. So let's write hash include avr slash io.h. This is the header file that we are going to use in all of our codes. Next we have to define a macro with the name fcpu. So hash define f underscore cpu and its value is 16 megahertz. Megahertz because it is actually the system frequency. The fcpu represents the frequency of the microcontroller and we are using a 16 megahertz crystal oscillator. So the operating frequency of the microcontroller is 16 megahertz. We have to define it so that there is appropriate delay in the delay statements. There is another header file that we need to include, that is hash include util slash delay.h. This is the header file which contains the delay functions In the next statement, void main if you have used C programming before, then you are pretty much familiar with what is void main. So in the next statement, we have to define whether the selected pin will be used for input or an output. We have to use the variable ddrx. The ddr is actually used to define if pins of port will be used for input or output. X is actually the port name. We can replace X with A or B or C or D. If we wish to define the pin as input, then we'll use 0, and for output we'll use 1. So let's see how we do that. In the first case, we have to glow 2 LEDs, and we will use pin 0 and pin 1 of port A. So let's define it. DDR, the port name is A, so DDR A is equal to, in brackets, 1 less than PA0, or again in brackets 1 less than PA1. So this statement defines PA0 as 1 and PA1 as 1. This is actually pin A1 and pin A0, and the value assigned to both of these pins is 1. Next, we have to give the output. For our first operation, we will glow both the LEDs for 1 second and then turn off for 3 seconds and then again turn on for 1 second. For this operation, we will use while loop. As we want the while loop to run for infinite times, we will use 1. This will run the while loop for infinite times. For defining the output given to the pins, we will use port variable. So the code will go like port A is equal to, in brackets, 1 less than PA0 or 1 less than PA1. The double less than is actually the assignment operator, which assigns 1 to the PA0 variable in the statement, and this is the ORing operation. Because we want both of these operations to be carried out, so we used OR. Next, we have to give the delay. For defining delay of 1 second, we will use underscore delay underscore ms. Here ms means milliseconds. So for 1 second, the value given to this function will be 1000. So the delay will be for 1000 milliseconds. After 1 second, we want the LEDs to turn off. So we'll just copy this and paste it right here. And we'll change the values given to this as 0. So after 1 second, the LED will turn off, and then again we'll give a delay of 3 seconds this time. So 3 seconds is equal to 3000 milliseconds. Okay, looks pretty much good. So next step is to compile the project. To compile this, go to build and build solution. You might not understand the whole thing for right now, but after we move on to the simulation part or the hardware part, you will understand how this code works and what is the significance of all these PA0, PA1 and code commands. So as there is no error in this code, we'll skip to the simulation now. So this is the Proteus software and this is the simulation environment. We can pick any component we want to simulate from this library. Just click on the small key and this window will open. We'll search for atmega16. And here it is. Click on OK and select this. Drop it anywhere in this area, and here's the IC. So let's first change some parameters in the IC. First parameter we want to change is the CKSEL fuses. This is actually for the frequency. As we selected 16 megahertz, so we have to select the last option, that is 1111 external crystal high frequency, and change this default frequency to 16 megahertz. That is 16 followed by 6 zeros. Click on OK. Now we are ready to go. But first we have to connect the LEDs so that we can see the output. So go to pick devices and search for LED blue. So let's select this active component. Okay. This is the LED. We need two LEDs here. So 1 and 2. Connect the first LED to the PA0 and second LED to PA1. We also need to give the ground. So you'll find the ground terminal in the terminals mode. Select ground and place it over here. Connect the negative terminals of both the LEDs to the ground. Now click on double click on the IC. Now we want to select the code that we have just compiled. So in the program file option, select this option and search for the code location. So at the studio 7 and let's search for LED pattern. Here it is, LED pattern, open it. And in the debug folder, you will find two files, that is .elf file and .hex file. We have to select the hexadecimal file. So .hex, okay, okay. So let's start the simulation and let's see if the code works or not. According to the code, both the LEDs should glow for 1 second and then turn off for 3 seconds and then again run in loop. So as you can see, the LED glows for 1 second and then turns off for 3 seconds and then again turns on for 1 second, goes off for 3 seconds, and this will run in loop for infinite times as we have selected 1 for the while statement. Let's try something else now. Now we will glow both the LEDs alternatively. That is, the LED connected to pin A0 will glow for 1 second and the pin A1 will be off for 1 second. And pin A0 LED will be off for 3 seconds and pin A1 will glow for 3 seconds. Let's build this code. There is no error. Let's see the simulation. Click on start and the code works fine. The D2 LED glows for 3 seconds, D1 LED glows for 1 second, and this runs in loop forever. So now let's connect 8 LEDs. Let's zoom out. So here I have connected all the 8 LEDs to the 8 pins of port A and connected the negative terminal to the ground, common ground. So let's go and write the code for this. For this code, all the pins of port A are selected as outputs. So the value given to all of these will be 1. There is one other way in which we can give the data to the pins. That is like 0B 0 0 0 0 0 0. Here all these zeros represent the data, the 8 pin data. This is the first pin PA0 to PA1, PA2, PA3, PA4, 5, 6 and 7. This is a simpler way, and this is a binary 8-bit code, or we can say 8-bit data. For writing this, we have to first define it as binary. We do it by writing 0B followed by the data. So as we have to define all the pins as 1, we will write 0B 1 1 1 1 1 1 1 1 8 times 1 for 8 pins. Similarly, here 0B 1 1 1 1 1 1 1 1. And for turning off the LEDs for 3 seconds, we will write 0B 0 0 0 0 0 0 8 times 0. Let's build this code. Zero error, so we'll go to the simulation area. Let's start the simulation. Okay, play. The LEDs glow for 1 second and turn off for 3 seconds. Again, glow for 1 second and turn off for 3 seconds. Okay, let's stop right there and do some other variations. Now I want the first 4 LED to glow for 1 second and other 4 to glow for 3 seconds. So we will give the code for this will be 00001111 and here 11110000. Remember, the first pin is to the right side and last pin, that is PA7, is to the left side. Let's build this code. Zero errors. Let's simulate it. The first 4 glow for 1 second and the other 4 glow for 3 seconds. There is one last thing I want to show you, that is shifting of data. So shifting of data is done by less than operator. This is an example of the shifting operation. This is the data we are going to give for each and every operation, and this is the shifting number. That is, we want whether we want to shift the data by 1, 2, 3 or 7 bits. So let's see how it works. In each case, the data is the same. That is, first pin is given the output of 1 and the shifting number changes from 0 to 7. If I shift, if the shifting number is 1, then the data is shifted by 1 to the left side. If the shifting number is 2, then the data is shifted by 2 places to the left. If shifting number is 3, then the data shifts to 3 places on the left side. And if the shifting number is 7, then the data shifts to 7 places on the left side. This might be easier to understand within simulation. So I'll write the code for it. For this, we will use for loop. I'm sure you are all familiar with the for loop. So first define integer I. Default value of integer I is 0. Semicolon. I is less than 8. That is, the code will run until the value of I is 8 and I plus plus, that is the increment. In the next statement, we will write port A is equal to 0B 00000001. Double less than, then shifting operator and the shifting number. Here the shifting number will be 1, which will be incremented in each step. So let's give it a delay of 1 second. underscore delay. The value given to this delay function is 1000. So the code is expected to run as the first LED will glow for 1 second, then the second LED will glow for 1 second, and so on until the 7th LED, until the 8th LED, and then again the first LED, the second, third, fourth, and so on. So let's build this project. And let's see if the code works fine. Start the simulation, play. It works fine. Each LED glows for 1 second and then turns off. That is, the output is shifted from pin 0 to 1, then 2, 3, 4, 5, 6 and 7, and then again to 0, 1, 2, 3 to 7, and this runs forever. So this is it for this video. In the next video, we'll see how to program a 7-segment display and LED matrix. So goodbye guys, and be sure to subscribe for the channel. If you have any queries, write them down in the comments. The codes used in this video will be shared in the description area. Goodbye and thank you for watching.